right. So with what y'all are talking about, I want to talk about it on video. So, we did not realize until afterwards that the Friday group that's not here is also the Thursday group that's not here. Which obviously could put y'all in a bad position, but it really doesn't. I am teaching today. We're doing 1 4-step for our last one, but we're going to write it as like confidence interval and test on the same page. So I'm going to go over the general 4-step for both of them. Then I'm technically only going to practice an interval today, which means tomorrow I'll technically practice the test. Wednesday will just be review. I've already posted the review online. So anyone who is in that Thursday, Friday group should be set up absolutely fine to take the test on Wednesday. And then if you have issues outside of that, let me know. But I think that will account for most people because the group that's going to get messed up Thursday, Friday will be fine to take it Wednesday. And then you can just take it in class. I'll get everything figured out. I might just split the room or something. I don't know. Questions with that I didn't just answer? Okay. So looking at 4-step that I just passed out. So with all the other ones, like we've written 4 so far this chapter because we did 2 sample means interval or 2 sample means test, 2 sample proportion interval, 2 sample proportions test. We have 1 left and we're going to put it together on 1 piece of paper for a 4-step. And we're writing it for both test and interval. So let's say we do something like a test. So like I want to know if I give you something we've already learned and give you a test on it. And then we go back and we add in review and then you take it again. No, that's a bad example. Think of a better example. Okay, let's say you're taking a test in different conditions. So like we'll just say it's like basic math, so it's not something we're worried about like learning over time. And let's say one of them you have to be listening to really loud music with really bad lighting. And then the other one, it's peace and quiet and really good lighting. And we want to know if that makes a difference. So it would not make as much sense to just do a 2 sample T or 2 sample test for means. Why? So let's say I'm writing this out. I'm explaining this a roundabout way because I'm kind of explaining the one part where people have an issue sometimes from the beginning. So I'm just going to write it as dark and light. That's the loud music. This is the no music. Let's say you get a 70 here and you get a 90 here. You understand that, right? And the next person goes and they get a 60 and an 85. And I can keep writing these out over and over. Could I switch this and write 85 and 90 and still make sense the way I explained it? Why did I write 70 and 90? What did 70 and 90 both have to do with? The way I explained it. Both of these had to do with one person, right? And then both of these had to do with another person. So would it make sense for me to switch those up? No, because these both go with this person and these both go with this person. So I don't want to do it like we've been doing it. What would make sense that I could do with those scores? Thank you. even know if I'm recording. Yes, I am recording. I'm just not doing that part of it. Thank goodness she's watching. Okay. So show it again so that people who are actually watching can see. This is person one. It would not make sense for me to switch and be 85 and 90 here because the 70 and 90 went together and the 60 and 85 went together. So what would make sense for me to do with those scores instead of just looking at someone that's a 70 and a 90? What do I know about person one? How much? How much better did they do in the light? How much better did this person do in the light? And so forth. Yes? Do I need these anymore? So I use these to get this number, and then basically I'm going to mark through all that. And so now, what do I say about person one? There's a 20-point difference. What do I say about person two? There's a 25-point difference. So now, is this a one sample or a two sample? How many numbers do we have for person one now? How many numbers do we have for person two? So we have one sample that's just the differences, even though we started out with two samples. And the whole thing is, each pair is matched up. Like there's a reason to put those two together. And there's a reason to put these two together. So it is called a match pairs, just like when we dealt with back in chapter 4. So this is 4-step process for match pairs. I call it match pair. Some books call it match pair, and some books just call it like a paired t-test. So just so that you realize, sometimes it's called, some books refer to it as match pairs, and then some books refer to it as paired t-test. I'm writing this one, like I said, as for both test and interval together. So this is number 11, and number 11 in chapter 10. On my sheet, I've got a little bit of space right here underneath where I wrote that, and I would suggest writing some things in here. This is only with means. Your sample sizes obviously have to be the same. And our samples are not independent of each other. And that's what I was explaining with like the circling them. If they're not independent of each other, that means there's like a reason to put them in a pair. You don't have to write that out every time, but that's just kind of a help you understand what to look for. All right, so what's our first part of state? What is our first part of state in all of the ones we've done this chapter? And what else do we define? Parameter. So are we dealing with means or proportions? Means. What's our symbol that we define for means? How many am I going to define? Just one. Because all I care about is the what? The difference. So we're pretty much always going to call this D. Or, I mean, technically you can give it any letter or number that you want, but I just always do UD. So this is the true mean difference Then you have your context population here. Now, we started out kind of with 2 samples. So with all of the ones this chapter so far, what did we have to do somewhere in state when we had 2 samples? We had to define the what? The direction. So we're still doing that. So in the example that I did on the board, this is supposed to say direction. What did I subtract? What minus what to get 20 and 25? Which one did we subtract? So I would write like parentheses light minus dark within my definition, and that would tell me which one I subtracted from the other one. All right, so now I'm writing it as though it's either an interval or a test. I'm doing them both on one sheet. If we are doing an interval, confidence interval, then what does the problem start with? So we want to estimate, what is it that we're estimating? I'm going to go ahead and write. I don't know why I do this one. I do the words before I do the symbol for this one. It doesn't really matter. The true mean difference what symbol? One thing I'm seeing a lot of when people are defining stuff, you always define it with a parameter, the one that describes the population, not the one that describes the sample. And then how do I end that? Because interval with number percent confidence. Confidence level percent confidence.
Define the population, or just give information
we would do it well enough, like we don't have to write it out specifically. So like, I think it'll answer it more in a question. Like when I do one, you won't really think about that part. And then something along the lines of, or it's either this one or this one. So if it's a test, instead of writing we want to estimate, I do what for a test? What's my null hypothesis going to be for this one? So far for this chapter, it's usually what right here. Like if it were means, we would do what right here. But it wouldn't be x bar because we're doing parameters, so it'd be what instead? mu1 minus mu2, but we're not doing that part, we're just doing ud. So our null hypothesis, so this basically is a chapter 9 one sample. We just start out with 2. What symbol has to be here? And then just like we've done this chapter so far, any number can go there, but what number is usually going to go there? 0. And then this is going to be HA UD less than, greater than, not equal to, same number. And then what else do I have in state with test? So this is the true mean difference, not the true difference of means. And that's why I get kind of picky first half of the chapter about saying the difference in means and not the mean difference, because this one is the mean difference. Plan, I start with what? And so now, you think this is gonna be 1 or 2? 1, because we've reduced it to being 1 because we only have one sample of something, the sample pairs. So it is a 1 sample. If I'm always given the pairs, so like, let's go back here to my example. I was given 70, I was given 90, I was given 60, I was given 85. My decision here is whether it's what or what. Before that, Z or T. Which means I would have to be given sigma like before, but now it would be the sigma of my differences. Did they even give me my differences? So would they give me the standard deviation of my differences? They didn't even give me the differences in the first place? No. So for these, it's always going to be what? If I don't know sigma, it's T. And then, so now I'm writing this one as, it can be either interval or test, because I'm putting this together.
What could do a thing where it says like since it's not given or not because it's on the field?
Here, it's almost like it'll never be given. So we like, anytime you do paired, it's like paired, oh wait. I want match pairs in there. Which would answer your question. I want to put match pairs before, like you can do an arrow down. So from what, I don't think y'all online can hear what the question was. The question was, do we not have to do like this since sigma not given? Because I put this, it's always going to be T. So basically this is why I don't have to write that above. All right, so what's my first condition? Back to my example here. What could be random about that? What? All right, so it could be random selection, which is helpful because then that's who we can generalize to. But we actually get a little bit more specific than this. If we don't randomize something, then there's confounding, possibly. Confounding is where we can't tell if the change is from this or this. The order in which they take the test. So the randomization, there has to be random assignment of the order of, and I'm noticing on stuff earlier this chapter, when I write treatments there, I mean like rather than context. So the problem that I did as an example would say random assignment of the order in which they took the light versus the dark one. And remembering back to chapter 4 a long time ago, this is when we did match pairs. So like you did a bug spray on one arm versus the other arm. Each person had to flip a coin to decide which arm to put it on. I didn't flip a coin once, and then everybody did this one on this arm, and everybody did this one on the other arm. Because with this, if I did like a flip a coin and then decided it was dark and made everybody do dark first, there could be confounding with other underlying issues of what the changes in the test scores were. So it's the random assignment of the different order. What's my next condition? Normal, what's a mean? So we have our three different ones again. What's our first one? What? Oh, stated. Stated population distribution normal. What's 2? Central limit theorem. Which is saying what? What is central limit theorem? N is greater than or equal to 30. Writing N is technically fine, but I'll come back to why I want ND to be greater than or equal to 30, but I'll come back to that later. Like writing in there is really not that wrong. All right, what is 3? Okay, now this is why I always make you write histogram of values. What is it going to be this time? It is the histogram only of differences. And so we're going to graph it, and just like always, we look for what? A strong skew. And how do we end that always? I'm skeptical of whether to say this or not. You're kind of seeming like this is getting repetitive, which is good. I like that part. But also, don't take it for granted that you're like, wow, this is so repetitive, this is easy. Because when this class took the quiz on Friday, 8 people in the whole class got the equations right. Just the equations up top. So I'm hoping this is getting repetitive, but clearly maybe you're overthinking things a little bit. What's my last condition? Which is 10% condition. So based off what I said earlier, what should I write here? So do D subscript with both of these is greater than or equal to 10 ND. Now technically, I started out with 2 different samples, like an N1 and N2. Why is it really not that picky that I write ND instead? Because what? You're using those, which means what's the difference between your N1, your N2, and your ND? Numbers wise. They all have to be the same. Because if you had 5 minus 5 of them, you should end up with 5 of them. And then write this one however you usually do. So there are at least however many, whatever.
I thought you said that the samples were not independent.
Okay, so the samples themselves are not independent. So like sample 1 versus sample 2 are not independent. But this person to this person is independent. And that's why, that's another one of those where some problems there are ways to get around just writing 10% condition, and I like to say, let's stick to 10% condition every time and not worry about the gray area. This is kind of one of those that gets really confusing. No, okay, so you had 5 to start with.
Yes.
And then you had 5 to start with. So if you took 5 and subtracted 5, you ended up with 5. Like if you had 5 people take it first and 5 people take it second, subtracting their first score versus their second score, you're different.
Still get
scores.
high score,
Yeah.
okay.
That was my wording. That's the thing.
Wait, so would you say there are at least like blank differences?
That's why I stopped and just wrote context. It's easier to explain the problem.
Okay.
One example, like your homework example is twins. So I would be like, there are at least this many pairs of twins. But it's context to context where that gets funny, and that's why I kind of just wrote context and stuff. But yes, that's a good question. Alright, do. So we're looking at this basically like it is a one sample problem, which means do gets really easy. What's a symbol we're gonna get from our data? We're dealing with means, so what am I gonna get out of my sample? And so it's gonna be x bar what subscript? And then and what goes with this one? If I get the mean, I also need the standard deviation. And all of these I'm taking of the differences. So I'm gonna write this as, what color did I use before? If it is a test, then I also need alpha. If it is an interval, then I would need what? And, which would end up giving me, and what do I get out of those two? So if it's a test, I'll write alpha here. If it's an interval, I'll have confidence level, degrees of freedom, and T. So if it is an interval, what is my generic equation here? What goes in the front?
X bar.
And it's going to be x bar d. Then what? What's my critical value? And then what's this part of it? Over what n? And the reason I keep talking about D, so if I had 5 people take the light test, the same 5 people take the dark test, I'd have 5 in the dark, I'd have 5 in the light, I'd also have 5 differences. But my standard deviation would be different if I was talking about light, dark, or differences. My standard, or my means would be the same. So technically D you can get modeled out in the subscript, but X bar and S you cannot. So if it is a test, what would our equation be instead? So what goes first? What about this? Where do I get that from? Just like we did in the last. So number, but technically it's usually 0. And then so over S of D square root of ND. What else do we also have with, so I get that, find my number, and then do what with it? What do I get out of that? and I compare my p-value to so basically it looks like a 2 sample, but it becomes a 1 sample, and once we've found the differences number, then we basically forget that we ever had 2 samples to start with, and everything else becomes a 1 sample.
Yeah.
Oh, yeah. Cool. What would be here? I conclude I'm writing it as both. If it is an interval, what would our sentence be? We are 100% confident and I'm going to word it the exact same way I worded the state. And then how does that end? Falls between. Some problems are going to be a little bit stranger than others, but because it's mean, what do I have with each of those numbers? And instead if it's a test, that's just our regular sentence. We reject or fail to reject. Our null hypothesis that mu d equals whatever our number is, it's usually 0. Why, since the p-value is or is not less than alpha. And now, because I taught you the shorter way, we can just say we do or do not have convincing evidence that what? Whatever the alternative hypothesis.